as usual, so I can send it to everyone a little later today. And I guess I just wanted to, first of all, look at the place that we ended with, section 1 of chapter 4, because this section actually works out lots of little problems in very, I guess, similar format that we already had done previously. So as usual, I'm looking at the skill building exercises, and I'm going to take a look at the so-called polynomials. So we saw this word before, right? So polynomial is something that does not have any radicals or any fractional or negative powers of x. So something like exercise number 16 is a good example of polynomial. And also the largest power of polynomial, that is called degree of polynomial, degree will be equal to 4. So we always care about the largest powers because that's the key concept that helps us to produce graph. So that's why it's so important to have degree pulled out. And I was thinking about giving you a quiz in the beginning of class, but I think looks like some people keep coming, so maybe I'll wait a little bit. So then we'll have something like that. So for largest powers, for degrees, I was able to get so-called family of these polynomial functions. So the family will be like exercise number 29, that's a degree 5 polynomial. And in that case, I will say this belongs to the family of x to the power of 5, or odd degree parabola-like polynomial functions. And with this kind of exercise, good morning. Have some people on Zoom that also here, and that's good. So for you'll be a little late. Okay, as long as it's better to come to class than say I'm late, so I just turn around and go back home and sleep. So it's better to still make it, right? So fifth power polynomial turns out is have an analogous graph to the cubic function. And remember, whenever they ask you to graph something like x to the power 5 subtract 3, like in the problem 29, we need to bring the whole picture 3 units down. So -3 will be now the intersection of your fifth power function with our y-axis. So whenever we subtract 3 or subtract any other number, we bring the whole picture down. If we do this with the entire equation x fifths, or with any other one. If we add the number, then the whole picture shifts upwards. So I just done exercise 29, and I'd like to go back to the beginning of this section to recall how these groups or families of odd functions will look like with respect to each other. So I'm looking at the fifth degree function right now. So in the beginning of this, I think they have done a great job showing this here in the figures. So I can try to make it a little bit bigger so you can better see this. Nice pictures. Figure 4. I was very impressed when I saw this. And as you can see, the cubic parabola that we worked a lot with in the previous chapter, x cubed, that has, they say, negative end behavior. One ends point upwards and the other points down, has analog as a fifth degree function that we just worked. It's very similar. The only little difference is that it shoots up faster, because when you raise something to the power of 5, it's definitely bigger number than when you raise it same number to the power of 3, because you multiply by that number again and again. Of course, if that number is more than 1. So if it's less than 1, it's like a half, then you take smaller a little bit. But the point is the shape of our odd-powered functions are, those shapes are always the same. They have one end points up and the other points down. And it doesn't matter, we have x to the power of 5, or like they have here, 9th power of x, that blue graph behind. 7th power, somebody can say, Alex, why did they miss 7th power? Well, they assume that you see the analogy, I guess, and that's the idea. So I think it's always exciting to read the textbook, right? And we can also try to look at the other family of even functions that, just like parabola x squared, both have, people say, positive end behavior. So let me clear this real quick. I'm gonna stop this share and then share this again. So here we have the x to the 4th power, as well as the 8th power. And they say whenever the degree here is even, then all graphs will have this so-called positive end behavior. Or maybe in a case if a negative sign is going to be attached. So if you considered y is equal to negative x to the power of 4, then the graph of that parabola will be reflected downwards if you had a mirror along x-axis. Why does this happen? Well, I guess because if you take, instead of y, negative y, and have it equals to the x to the 4th, so you changed y with minus y at that same value of x. So that's where reflection happens. But then you can negate both sides, so you can say, bring the minus over to the other part of equation, because we're always trying to isolate unknown y. So I guess this idea of problems that we've done in the previous section is now going to be utilized in this section as well. And that's the main power of college algebra. So you no longer care about making those little points, plot them, and then connect them. You just look at the equation and you say to yourself, oh, this is degree 5 or degree 4 polynomial function, so why don't I just graph it right away without any of this point plot and point calculation? And that's the whole idea of what we're learning. So for example, in exercise number 27, I have the x plus 1 to the 4th power function. So it looks like we just considered the way the graph of 4th power function looks like, x to the power of 4, right? Just like a favorite parabola x squared. Now, in the actual exercise here, we have the x plus 1 in the parentheses raised to the power of 4. So what happens with a graph in that case? Well, since 1 is in the parentheses, then we're going to have this x to the 4th above shift by 1 unit horizontally, not vertically, not up or down, but actually 1 unit to the left. So this way, we get a graph of that blue function x plus 1 to the power of 4. Remember, main justification why this happens is because first thing you do is what's in the parentheses. So if in the parentheses you added 1, well, then you add 1, so you shift this whole picture 1 unit in a bigger area, which is right. So you return that blue one where the original force power graph was. So I guess that's the idea of resemblance of these groups of even and odd functions with each other and with graphing what we've done before. And again, the key idea is to find so-called degree. And that's what I wanted to ask you to try to do if we look at the next, for example, group of exercises here, like in a problem number 49. Let me give myself a little bit of a room, so maybe I can actually share with you a new screen for that. So an exercise 49 says, look at the function. So you can call it as f of x, g of x. I usually call it as y, and it's the same thing. So we have two parentheses multiplied. One has x minus 7, not plus 7, but minus 7. So let me try to get this clear a little bit. And then another factor here is a x plus 3 squared. Okay, x plus 3 squared. So I want to decide what will be so-called degree of this polynomial function. And it turns out that degree should be 3 because the power of first parentheses is not shown, so it should be 1. And the power for the second parentheses is 2. So when I add these, it's 3. It's just like when you multiply x by x squared, then the powers of them have to be added, and that's going to be x to the power of 3, right? When you multiply exponents, you add powers. That's the same idea here. If you decided to actually take pains and distribute all that, that's gonna eventually end up with a cubic polynomial function. So if you will think about family of degree 3 functions, then you will have something with one end going up and the other going down. And to actually continue with this, to graph it, I can find so-called intersections with x-axis. X-axis intercepts, remember? Those were favorites. And, oh, good morning. How are you? So that's nice to hear. Glad you're here, in spite of everything. So we set this equal to 0. Because when we get x-axis intercept, then y coordinate must be 0 for that point. So that's our so-called definition. So when you are going to set y equal to 0, instead of f of x, you can put y and make it equal to 0. And then from first parentheses, you see that x should be 7, because when I plug 7 here, then parentheses turns into 0, 7 minus 7. And from the second parentheses, x will be what? 3? Negative 3, because minus 3 instead of x will be turning my first parentheses into 0, but there is a power of 2 here. So we say it's order 2 intersection with my x-axis. So if I decide to graph this cubic function, cubic again because degree is 3, then we put those intersections, such as a 7 and -3 on my x-axis. And then I'm going to have to recall that order 2 will be a polynomial that similar to x squared, that just touches my x-axis. So the point that I'm trying to make is that we're going to have the graph that touches x-axis and then bounces back. And notice the end behavior, the function keeps going up all the way on the right. Then eventually we're going to have to go down and intersect our graph at point -3. So the key idea again is, if you know the degree, the largest power of your polynomial function, well, then you already know the family that it belongs to, and then you can produce a proximate graph. Of course, the other interesting and important point would be this turning point, or so-called maximum of it, but that's what you're going to learn in the next class when you learn so-called derivatives, how to find. So I think that's interesting type of exercise, and I'd like to try another one here, similar to graph, with a little different powers, so with a little different degree. So how about the next one, exercise number 50, that says, Alex, graph, I will write it as y. I like to write it as y, which is the same as a 4 multiplied with x plus 4 and x plus 3 in the parentheses cubed. Okay, so I'm gonna think about degree of this polynomial function again. So what do you think the degree is? Sounds very good, indeed. I like that. That's 4, because this is first power for the first parentheses, and we have third power for the second parentheses. So this is degree 4 family of functions. It's analogous to x squared with both ends of this parabola-like graph pointing upwards, just like that. So we'll keep this in mind and decide about so-called zeros, or what makes my y equal to 0. I say, Alex, you just called them x-axis intercepts. Well, that's the same thing, intercept. So from setting this to 0, I can see that my first parentheses turn to 0 when x is -4, right? Let me plug -4, and second parentheses when x is -3. So we've got 2 points of intersection with x-axis. So let me put them someplace here and here. They kind of close to each other, -3 and -4. And then we need to have both ends of this graph pointing upwards. So how can I do this? Well, I can produce the graph somehow that points upwards, just like that. So at this stage, that's the best I can do in order to graph that function. So intersections with x-axis, I guess, is a key pair of points. And of course, finding those degrees is what's the most important. So let me try to do another exercise, and then maybe you can try for a quiz also to find degree. I'm sure you're going to like it. So how about if I try something that looks like not that nice? Oh, sure, absolutely. See, it was covering. Yes, just a sec. Let me share this back. Yeah, I will email you a recording because as usual, I'm recording this. But anyways, if something is here that needs to be clarified, please let me know. In fact, in the meantime, what I can do is kind of support the idea that this graph is indeed the graph of fourth degree function by trying to use a tool called graphing calculator.
What I'm doing, but it's just like something different.
So let us use it together. See, I know that some people have access to various tools, so let's do some technology. X plus 4 and then x plus 3. So let's try to get this. I'll share my screen again. And x plus 4 and x plus 3. So let me get this. Yeah, that's interesting. So you can find a free graphing calculator on Google. Just try to start typing graphing, and there's graphing calculator available. So you don't have to buy it. They're pretty expensive nowadays. So we just have to use this lower keyboard in this corner, so that way you can actually start entering data in the line. So I believe it was 4 in the parentheses multiplied by x plus 4. So, and then x plus 3 cube, right? So x plus 3. So don't look at the graph at this stage because it's still not what we need. Now, how do I enter cube? Well, here's the way to use the power. There's a little key on this menu. So I just click on that. I want to make sure it's X. I want to enter what I need here. And then the third power says cube here. So it looks like that's what I produced in here. And you may see the resemblance with the end behavior. The ends that we had look like that, right? But I see what you have noticed. There's a little wiggle here, right? In between of numbers 3 and 4. So what I can do is try to do this, zoom in a little bit so you can better see it. Well, that's what you're going to do in the calculus class. So you're going to be able to find exactly where that lowest point is and where the other point, so-called inflection, is. That's where it's going like a parabola that opens down and then all of a sudden changes behavior. It starts going like parabola going up. So here it's like a parabola that goes upwards, but then it's like a parabola that goes downwards, and then again starts going up. So that's so-called inflection point. So where it changes behavior. This. Here's one, but that's what you're going to learn in the next class. I'm glad that you're interested. This is not what we're doing here. You need so-called derivative to find, and then second derivative, make them equal to 0, and that's how you find it. This is not what we're learning, but I'm glad you're already learning it little by little. That's super impressive. And that's a flavor of what you're going to learn if you decide to take, say, calculus for business. Maybe you don't have to, but it's going to look impressive on your transcript as elective. Anyone would transfer extra math class in university as elective and say, oh, no, I'm going to take communications or something. Everybody has communications as elective or something. Who has math, right? So think about it. So it's just the same as challenging as we're doing right now. It's not getting any more difficult. So anyways, the free calculator, I'm glad that you already know it. It's Desmos. It's otherwise may cost you a little bit. So what I do is I'm gonna put this in chat for everyone. Then you can just click on that link that I just put in chat and bookmark right? When you have something that you want to save, here's a little star, you can bookmark it, and that way you can always find it without all this searches on Google or whatever else. So this way, you can always check your work, and I'm sure it's fair for me to share this with everyone, because if some people use it, some people don't, it's kind of not fair. So it should be equal with everyone. So anyways, let's look at the exercise with another degree. So I'm not gonna try to graph all of them, because we actually here not to graph, but to find degrees. And I just saw an interesting problem like number 57. Well, in the exercise 57, we actually have a power x squared inside the parentheses. So notice that when let me write this here, 57. Look at the coefficient 3. That makes no difference for us. It still keeps same shape. If it'd be negative, the graph would flip, right? But it's positive 3, so doesn't matter for degree. So in the first parentheses, I have x squared. So I already know that the power here is 2. Well, in the second parentheses, it's x squared plus 9. Well, for x squared plus 9, I have power of 2 here again, but it's raised to another power of. So it's like 2 times 2, because when you have x squared to the second,
That's where we get a plus or minus answer.
so here we trying to get degrees, so we have to still add all of those, but this is going to be x power of 4. You see, because x squared and squared, it's x squared times another x squared, so it's 2 and 2, 4. So we multiply the powers. That's a little formula that we have in here. So that's the one we're talking about. So because of that, our degree is going to be 6. And if you decide to graph this, which is going to be done at the end of this chapter, we're going to look at exercises of this kind. You're going to have a positive end behavior. So both ends will go in the same direction, just like for the 6 power polynomial, just like x squared, x to the 4th that we just saw. 6 power is also positive, same direction, ends. But as you just noticed, there might be some wiggly structure in between because of this inflection, whatever, but that's not what we're gonna really care in our class. But later you would be able to discover this. So let me do one more, and then I'll have you try one for a little quiz. And if you can't do it, just came in, you can work together with someone. In fact, if you would like to, you can just sit closer to someone, or you can just come to me. I can, of course, help you, because goal of quiz is make sure that you get on the same page with us, not to downgrade somebody. No, just to make sure that you see what's going on. So let me do the exercise like number 56, and I'll have you do 59. So let me try to clean this mess again a little bit. Here on the left of it. So for 56, looks like we have 2 parentheses, and they both raised to the power of 2, right? And I say, what's with that square root? That's part that bothers me. Square root plus 3. It doesn't matter if that's 3 or square root 3. X is what we care about, our variable. The numbers, they can be any real numbers whatsoever. And this is the way it is. So we got x minus 2 to the power of 4. So to find degree, right, you made it, right? So I have to add those powers together. So I have to take the 2 and the 4 and get 6, right? Add them. So don't look at them. Add them. That's how we get degree, those powers. So how about if you try to do exercise number 59 as a little quiz? So you can do it and I will look at it, and you can either put your answer in a chat, or you can put it on a piece of paper and show me, or you can show it to someone next to you so we can work on it together. So, and if you don't put it in the chat, you can just use a little paper and write it. So again, what I care about is degree, okay? So keep track. Yeah, just write your first name and last name. Don't just put very big letters. I know some people make very nice graffiti-like things, but I want to make sure that the other people also fit there. So thank you. Thank you. So yeah, we'll have like what, 5 minutes or so for a quiz, and then we're gonna continue. We're gonna do a little bit more of this nice stuff. In fact, I had a question today to do an exercise in completing squares. So I'm gonna return back and we're gonna refresh some stuff from a previous chapter, from chapter 3 or chapter 2 or chapter 1, if you like. So whatever you have in mind. Yeah, that's pretty good. In fact, I'll graph this after that. So if you're trying to graph it, we'll graph it. I think that's a very good idea. But anyways, take your time, don't hurry, and make sure that you find degree. So all you need is, again, look at problem 59. It has x squared, another x squared, and it wonders what's the largest power of this polynomial. Alex just came in, what's the largest power? Maybe you can just see what this polynomial is. Maybe get rid of parentheses, and then you see what is the largest. That could be the way. Okay. So again, 59, this is product of those two facts. What will be the largest power? We're done. Was this done? You can tell me. Somebody already done. You can this. You can do that. So you can help each other. That's absolutely. Yeah. It's one.
But because and then you focus again, so it's like yes, there you go. I mean, yeah.
I like it. When I like it.
That would be very the physical meet the outside. I mean, honestly, but here because getting close to thank you so much. It's just, it's just like, it's like a different, like, so it's basically like, outside of nature. No, not multi, because it's not like a different. Yeah, okay. This comes with the door and carry. And you feel like here. It's like, like either. That's the thing, like, I was like, I was guessing. I was thinking that, I was like, oh. Yeah, no, yeah, that's like. The degree is like. So just. But then that would have been sad. Not, I remember like,
Sometimes you multiply.
so sometimes.
Yeah, sometimes you multiply, so let me get this. See, when we multiply is a case when you have a power raised to the power, it's right here. See,
Oh, okay.
when the power is raised to the power, then multiply.
You multiply that power by the power
Yeah, power of 2 times 2, so.
4.
Okay.
Yeah, thank you.
Only different, largest power was the real is. Which is that all of the roads, and that's part of the. So we can go. Now. Yeah.
They were terrible, but I have to. Yeah, which is why you don't have the. Everything just feels like about anything else. You did. Basically,
Yeah, okay.
Thank you.
Power. The power here was. The largest power is your degree, and the largest power is. Yeah. When you do it right, they can stop it. Really appreciate that. I mean, but somebody else. Everybody's finished. So I also told you to put the answer in the chat, in the Zoom chat. If you. Oh, that's all you. Yeah. So it's needed to be by the excluded. Super, so whoever didn't put the name yet, please do that. If you don't feel like doing it now, you can always email me your name, or you can always email me your work, and that's fine. So I got, okay. Okay, so I guess it's a good idea to move on a little bit. And again, if you didn't put your name on this list, please do this. I think everybody finished, but maybe I forgot to give you the sign-in paper. So don't be upset. I didn't do it on purpose. I said, oh, that student, I'm not going to give them the paper. It just got mixed up. So you can always come over. Don't be shy and put your name. So anyways, I'm looking at exercise number 59. Let me actually try to graph it. I think that'd be a good exercise to graph. So I'm going to share this little board and try to graph 59. Let's see. Here it is. So it looks like that first term here is negative. You see minus, it's negative 2x squared. Remember how these negatives behave? They point down, and that's the idea. So I guess the, oops, I was misclicked something. Sure. So it looks like I need to, some people actually made me very impressed because what they did, they just distributed and ended up with negative 2x to the power of 4. And negative is positive. 2 times 2 is another 4x squared. Right? So that what tells you that your degree is here, the largest power. It's 4. And I like when you do it right. So we're in the family of even polynomials, like squared, 4, 6, right? So both ends go up. And that's great to know, but the negative 2 makes it actually flip. So if we consider this negative in front of our x to the 4th, it's flipped. I say, Alex, but that's negative 2 you have, not just 1 or nothing. Well, if it's negative 2, it's just like with the case of squared, the graph gets contracted. So what happens is, maybe I can get a better picture of this separate. So if we have parabola like x to the second power, or I can look at x to the 4th power. So we double the values. What happens with y coordinates when we double those values? Well, it turns out for any point x, if I find y, which is a 4th power of x, now that's for this red one, I multiply it by 2. So I double it. In other words, the distance from x-axis doubles. So if this point is here, I double this distance. If this point is here, I double that distance. And that's what makes my graph, people say, to contract. So the shape of it is not going to change at all. It's just going to get closer to y-axis. That's the contract, it's skinny. It's twice away. So here, twice away. That used to be on the distance, the red one, now it's green one, is twice farther from my x-axis. So that makes it be contracted. But again, for the shape of graph, I'm not really that picky. I know it's contracted a little bit, and that's all. So it still opens downwards. And besides that, we can find the favorite interceptions with x-axis. Again, y is equal to 0. Those will be our favorite points from now and on. So it looks like we have the 2 parentheses that we should send or make equal to 0. So first factor here, And the parentheses that had x squared in it is also 0. And I also noticed that some of you did that, and that was very impressive because you went one step ahead and found that x was equal to a square root of 2 or a negative square root of 2, which you can write as plus minus square root 2, indeed, but there are two of them. Negative squared or positive squared, they both end up being 2, the square roots. Yeah, because when you replace back your square root here, or in other words, you check, right? So how do we solve? How do we get rid of a square? With square root, the opposite. But as long as you do it on the left and on the right side. So if you, let's say, plug in your square root 2 here instead of x and square it, you get 2. You say, Alex, why is it a 2? Well, you can check it with a calculator, for example, or you can multiply square root 2 by square root 2. It's a power of 1/2, square root 1/2. Add a half and a half, you get 2 of those halves, which is 1, which is x. Yeah.
So the y equals x to the fourth, that's the degree that you just grabbed.
Exactly, the fourth degree.
And the y
Largest power.
equals 2x to the fourth is the change in the angle of the graph.
Yeah, it changes shape a little bit, but it still stays like a parabola shaped function.
So we have to graph both the degree and if we have any number in front of the 4 in the original equation, that we have to.
It's up to you. It's up to you. You can graph, you don't have to, but the idea for the exercise that I'm doing now, I'm trying to get the end result right now. So I'm still in the middle of solution, but eventually both ends will point upwards. That's the main idea that we have here. Okay, so good. So looks like we can see that if it's x squared, there are always two answers. Notice that here's another equation with x squared. So to solve it, I can say divide both sides by -2. And I notice that 0 order 2, because it's another 0 actually sits behind it. Because it's x squared, so you can factor with x times x. So let us try to make a picture finally of this fourth degree parabola-like function that opens down and has intersection at point 0 and another intersection with x-axis at +2 and -2, or square root 2, square roots 2, like that. So first of all, I prepare those 3 special points. Now I recall that both ends go downwards because it's a negative in front. Okay, so one end of it goes down and so does the other end. And now to connect, I have to go and touch my x-axis at the origin, at the point 0. So this way we have a graph. Notice one very interesting fact about this graph. It is symmetric through y-axis, right? It's like a y-axis symmetry, and it's not surprising because this is so-called even function. Remember, evens, and it's composed from both even powers and x squared and x fourths, so they're both evens. When you add them, still going to be even function. So it's symmetric with respect to y-axis, just like even power of x, parabola x to the fourth or x to the second, they're all even, symmetric through y-axis. So you can try to graph this with your graphing calculator if you feel like it, and double check if that works, if that's similar. I think that'd be fun. So, okay, so now as promised, I'm gonna return back to the previous chapter. There was an exercise that I was asked to do here. There was exercise number 24 and 3.3. So let me go back. Again, don't worry, I'm recording everything, so I will send it to you in a few hours. So this is section 2.3. So how to get faster to that section? You can click, oh, there's no clicking here. I think it's in the beginning of section, right? Let me go to beginning of section. That was completing of squares. I think it was 3.3 section, right? So, see, it's annoying when you start browsing through this electronic books, but when you click on this 4.1, you see my cursor changed to hand, so you can click on it. It brings you back to the contents of this whole story. And then I can go to 3.3 section here in the contents, and this way I'll get faster there. So number 24. Okay. So let's do this little exercise in completing of squares. That's another part of the story of graphing. That's finding those vertices, right? So let me get this bigger. 24 wants you to find the vertex. So let me go with the sharing. Let's see, something is happening. I think, where's my Zoom? Okay, so I'm not sharing screen. So let me share the screen. And I will actually go for the board. Okay. So I'm gonna get next page for this little board and do 23. So this is actually 24. So this is again, section 3.3, exercise number 24. And you can easily find it, and very quickly, if you just look at the page here on the right side, you can see 176. You just type on the right 176 instead of doing all this tedious manipulations. So they say, look at function x to the second minus 6x and minus 1. That's a parabola, right? Parabola that they want me to graph. Why parabola? Well, degree of this is what? What's the largest part? Degree is 2. So it has to be my old friend parabola that opens upwards. So it's going to be going somehow like that. And both ends go up. But if you decide to use the same ideas that we had in the previous section, the intersections with x-axis, I don't think you're going to find them because it'd be hard to factor. I say, I'll use quadratic formula. Well, you can try, but again, let me find the vertex. That's what the exercise says. So how we completed squares, because the issue here is with this negative 6x, because negative 6x is on the way, you see? this minus 6x is really bothering me because we have x term. So I want to take a half of it. So always divide number 6 by 2, and this is going to be 3, right? So I add 3, don't forget to square it, and subtract that 3 squared, which is 9. So I actually add 9, and then I take away 9, so I didn't change anything here, but my first 3 terms will give me that perfect square. They will give me a perfect square of x, the first, and 3, the last. And I see negative, so it must be a minus. And then the other 2, minus 9 minus 1 is negative 10. You can always check this out. You can always multiply them back. Why not? You can see what is x minus 3 squared equals to, and it will equal to x minus 3 times another x minus 3. So when I multiply, we FOIL, multiply first terms, you get x squared. Now terms on the outside and the inside, FOIL, outside, inside. So this be negative 3x and another negative 3x, right? It's, look at that. It's Alex, enough, I see it. It's minus 6x. See, that 3 that we had as a half of 6 came out because there is 3x and another 3x, so twice. And that's why to get that 3 we divide. And it's always like that. And then finally, last term, so multiply negative and negative, we get positive. 3 times 3 is 3 squared, or 9 if you wish. And this is it. I have my vertex now. I have the vertex, which is what? I subtract first coordinate of it from x, which is whatever is in the parentheses. We change sign with the opposite, minus with a plus. And then I take the way the number is that negative 10. So this is my vertex. So once I found it, I'm pretty much done. I can graph my parabola. 3, negative 10. So whenever you graph, you should clearly mark it. So everyone, like Alex, can see what the vertex is, and that's it. And I can definitely give you full credit for the exercise. And this vertex goes, the parabola goes upwards. And there is one very interesting thing happens here. Remember, intersection with my y-axis, y-intercept. Just like for the line y-intercept, always that number at the end, same here, negative 1, is exactly that y-axis intersection of my parabola. So that kind of double checks if you did that correctly. And once you're done, it's 24, I guess that's a good exercise. I hope that you like it. And I'm glad that you're actually redoing the problems, because these problems, they do deserve extra attention. They do deserve extra attention. So maybe I should do another one like that. What do you think? I think so, because this part of the course is probably the most tedious. This algebraic procedure is the most tedious. But when you graph later ellipse, a parabola, you have no way around. I know in the book they have a little shortcut, but then when you get to ellipses, you still have to do it anyways. So I think it's good we do it now, and then later, when you see it again, you say, oh, I already saw it. I like that. Or not really. But anyways, let me get one more. Let me get one that starts with a minus sign for a change. I just saw one. I think it's worth trying. Like problem number 33. Exercise 33. So it's still the same section. It's still complete in squares. So this exercise has minus x squared. You see, for a change, it's gonna open down minus 6x. So how do you feel? I'll do this one and then I'll have you try to complete one square or not really. Let me know. So anyways, this is going to be from parabola family that opens down because of minus with x squared, right? It's like that. Minus. Okay. So I'm gonna do what? Well, I can actually solve this by finding the intercepts with x-axis, set it equal to 0, because this one begs me to graph it, or you can also complete the square. So let me do that. So first of all, we always want to make sure that our x is clean to use this procedure, or you can complete square any other way you like, if you know how to do that differently. If you have a good tutor that's shown you alternative approach, it's absolutely fine with me. As long as you do it right, I'm okay. So anyways, what I just did, I changed both signs because I want my x squared to be positive. I don't want to have anything in front of it. And then I pick on that 6. Remember, it bothered me last time. Now it keeps bothering me again. So I take a half of it, 3 squared, 3 squared, and then subtract that same exact number, the 3 squared, 9. So I add 9, I minus, subtract 9. I do nothing with this expression. It stays same. So we can put this first 3 terms in the parentheses squared. And that's the reason why I do all that. I want to complete that square. So what's inside the parentheses? Well, first gives me x, last gives me 3. And that 6 is just half of it. That is very tricky. Oh, I just took half of 6. See, that's the point. So where do I get that 3? Well, it's a half of number with x. That's where it's coming from.
That was a number 10. Did you do half of 10?
Yes, half of 10. I added what? 9. So I have to subtract 9, because if I all of a sudden add 9, well, it's going to be something different. I want the same thing. So add 9, take 9 away, so it stays the same. Looks like everything inside is positive, right? Inside of this first 3 term group. So this is a positive. And then minus 9 is still there. And the square was completed. And that's what I needed. So what I'm going to do is put a minus, and then I'm going to have this big parentheses. So I'm going to distribute this negative over, right? So yeah, took out negative. Now I have to bring it back again. So it'll be minus x plus 3 in the parentheses squared and plus 9. And I can write what my vertex is. Vertex is going to be coming from here, change sign, right? Negative 3, and take the last number the way it is, positive 9. So once I have vertex, well, I graph this parabola that opens down, minus 3 plus 9, the vertex, someplace here. So it opens down. So it goes through the origin, turns out. This parabola hits 0 on y-axis because there is nothing here at the end. So its intercept is 0. You see that? So it hits exactly where x-axis intersects y-axis, or 0 on y-axis, y-axis intercept.
I still don't get where that 9's coming from. Sorry. Is it the
Half of 6. So half of 6 is 3 squared. See, you add this on purpose to make it be a perfect square. So the second number, 3, will be squared. So that way we have parentheses squared. So that's how we get that 9. This is a procedure that I would say worth to do again over the weekend. I think that'd be a good idea to do this again. So on Monday, we'll keep discussing more of these things. And in the meantime, I'd like to maybe have you try one, right? Let's try another one. So we'll try one more exercise. Now with these ideas to just match the graphs. So I'm gonna share this little page with you and have you try. Let me make it look bigger. I think exercise number, I wanted to give you 13, but some people say, Alex, no, I don't like 13. 14. Okay, let's do 14. I think it's very similar. 13, 14. So how you try 14? Well, you should find what graph corresponds to this equation. They already gave you graphs. So what you can do is just put this either in chat, what letter corresponds to this graph. So let's say you say letter A or letter C. Well, probably C is not, because that's a x squared moved down, right? So it's not what we have here. There's 2x added, and there's plus. So think about number 14. So how would you do this? And then we can try to do it together after that. So take your time, don't hurry. I think 14 is a good example. Hope you see it. X squared, 2x, and then plus 1, right? And then if you need my help, please just let me know. Or you can work with someone. Yeah. That's a nice exercise. Two, right? 2 is the number I want to pick, right? 2 is what I have to do. Any alphabet, exactly. That's the way to go. Capital 2, 1, very good. So if we have 1, oh, you already done? Okay, so capital 2, I know it may be a little bit tiring, right, already. So I can do what? It's 1. Then I can help you a little bit. So it's going to be x squared and 2x, and I need to maybe keep that thing away a little bit and then put half of 2, which is 1 squared. Well, 1 squared is 1, added 1, subtracted 1, nothing is changed. So these 3 will boil to x plus 1, first and last, right? That's all I care about. And then these two guys, they nicely canceled. So what's the vertex? And you say, Alex, I can tell you what the graph is. It's just shifted by 1 to the either left or right. So left or right. When you add,
It's positive as well.
So it goes the opposite direction. So it is actually part A. It is part A. How about that? So vertex will be a pair -1 and a 0 because the y coordinate is nothing. It has to be 0, right? There's nothing added here. I see that's pretty sad. Nothing is added. Well, doesn't matter. Whatever they add or subtract, it's really same thing. So I hope you will try to think of it again, because what I plan is to give you a completing square exercise on the midterm. So for the midterm, we're not going to be in class at all. So don't worry, I'm not going to just look at, when I'm around, you start doing it, it kind of not feeling comfortable. So you will be on your own, wherever, whatever place you like. So the midterm will be on Wednesday. Let me write this here so you'll know. So midterm will be next Wednesday, a week from today. And I'm going to email you practice midterm over weekend so we can together do problems. One of them will be similar to completing squares. So on Monday, on Zoom, we'll be on Zoom. So on Monday, we'll do problems from the midterm. So I'll give you a good review for the midterm. There'll be only 2 exercises, and give too many. 2. I think it's fair, right? So 1 exercise completing squares, and the other will be graphing with all the moves, left, right, up, down, maybe flip. So we'll do another one like that. So I'll send you this midterm and check your email before Monday. Maybe you can even try to do it. The only difference is I use last digits of student ID of yours to produce different answers. Since you're not taking it in class, so I don't want everyone in class get exactly the same answer. It's pretty easy sometimes. Sometimes students I know use cell phone and send the answer to everybody, and then I see the whole class got the wrong answers. It's not what I want. I want you to get the right answer, but I want you to also practice a little bit. And that's why I use your last digits of student ID. So you have your student ID, there are 2 last digits. So one student has that digit, the other has that digit. So that way the answers are not identical. But the problems are the same. It's the same procedure, but a little different answers. That's the idea. And that's why I'll send you practice. So on Monday, we're gonna on Zoom talk about this. And then on Wednesday, I will also email you exact same way, a PDF file called midterm. And I will wait for you to email it back to me. And that's how we're gonna go about the midterm. And now I'm ending it. I know that it's a long weekend coming. So in the spirit of long weekend, I guess enjoy this. It's a Veterans Day weekend. I have another day, Thanksgiving, that we're gonna miss. So we'll see how can we approach that, because it's on Thursday, Friday, all the way to, and our class is Wednesday. So next day is Thanksgiving, and then back on Monday to school. So it's kind of unfair, right? But don't worry, I'll maybe give you less on on Wednesday, Thanksgiving week. But I see that you are doing some studying that makes me happy. So I'm sure you're gonna get pretty good grades on this midterm exam. And also homework, whatever you've done. So some people say, Alex, I've done just 2 problems. Well, send me what you've done. Do the same problems done in class. You did something, so you can use this as your part of your homework. So whatever you've done, make pictures, email it to me. That'd be